So we're going to speak about main considerations, key points to keep in mind while developing the first time for wearables devices. So before getting into the actual session, I would just like to introduce myself first. So my name is Daniel Neamtu, and I'm a developer advocate for Zebra Technologies. I primarily cover the EMEA region, and I've been in the company for 7 months now, so relatively still new. I have 7 years of Android development experience, so I've had experience with custom ROMs development, applications development, and pretty much now I'm into Android development enterprises. So we, from Zebra, sponsors, so we are sponsoring droidcon, and we have our booth. So if you haven't come across yet to our booth, make sure to give us a visit in case you want to know more about our company, in case you want to know more about what we do, and of course, if we are going to have any questions about this session. Right, so talking now about wearables. When we speak normally about wearables development, we typically don't talk about creating applications for Wear OS-based smartwatches, because essentially when we speak about Wear OS smartwatches, we typically intend development following specific guidelines, because we know that Wear OS has specific guidelines and documentation on how to develop on it. But normally wearables, it's more like a general approach, and we can see wearables in different areas. So we can see wearables in different form factors. We can see wearables being used not just by the end user, but we can see wearables being used by in enterprise use cases, and we are going to see about that later by the end of the presentation. And of course, we can see wearables being based on different variations of the operating system based on Android. So of course we have Wear OS, so we all know Wear OS obviously. Then we have a second category where we can have proprietary OS. So for example, in this case we can see on the left Fitbit smartwatch, and on the right side a Garmin running its own proprietary flavor OS. And then there is another third category when things gets really interesting, when we can also have wearables devices being based on AOSP system images. And in this case, we can have like a wearable running Android applications like on any smartphones, for instance. And in this case, the wearables which you are seeing in this image is actually one of our latest devices, which is called the WS50. So WS50 is a very interesting device because essentially it can be used in different areas in talking about enterprise use cases, obviously. And just to give a little hint about it, it has an AOSP, is running an AOSP system image, so running Android 11 in this case. It has Wi-Fi, Bluetooth, and NFC capabilities. It has only 1 gig of RAM and 8 gigs of flash storage, so pretty limited on that, but that's really common when we speak about wearables in general. It has a 2-touch display, 2-inch touch display. It has removable battery with hot swap support, so it has a capacity of 1,300 milliampere of power. It is fully ruggedized, so it can actually survive a 6-feet drop if you really want to drop it. And it has 2 different data capture options, so you can actually have the camera, which you can use it while wear it on your wrist, for example, for different use cases, or you can also use the imager, which is the one being used when you want to perform barcode scanning or all of those different operations. It has push-to-talk capabilities with the embedded speaker, so that can be used also for situations when you have to push-to-talk while performing different operations, maybe in a warehouse, for example. And it has the common power buttons and side buttons, which you can also remap if you want to use them for different actions in your application. Okay, so now speaking actually about the main differences between mobile and wearable development. So the first thing to keep in mind when developing for wearables is that you are pretty much always going to have the necessity of using specific APIs to perform any kind of operations. So usually, even if you're going to develop for Wear OS based smartwatch or for any other wearables being based on a proprietary OS, you're always going to face the necessity of using specific APIs in order to perform specific operations like sensors, management related or anything like it. So even when talking about custom libraries as well. UI and UX, obviously very important part of the development when talking about a wearable application, because the UI and UX is fundamentally different from a smartphone application. Then we have functionality. So functionality, so when we speak about functionality, we're typically talking about features which are meant to be put on a wearable application. So we really don't want to have features in a wearable application that they are not meant to be used on a wearable device. So they can become pretty much useless, or they can also create discomfort in the user's case. And then lastly, we have navigation. So same as the UI and UX, navigation is completely different from a smartphone application, from a mobile application, because also the workflow of the screens, so of the layouts or fragments, anything you want to use in your application, is going to be different from a typical smartphone application. So talking now about a couple of the principles of the wearable development, and here the first one, which is actually the very, I guess it could be considered as the main important principle, is about designing the application for critical tasks. So essentially, this actually connects to what we were also speaking about functionality. So we want to design our application for wearables only for a handful of tasks, which the user will then perform to make it life easier. Because whenever we use a wearable device, for example, we want to use applications in order to don't try to use a smartphone, but instead we want to use wearables in order to simplify specific actions. So this is one of the main principles when talking about wearable development. Second one is about optimizing your application for rest. So when we speak about optimizing your application for the rest, we are speaking about creating the features, the UI, and the application itself in order to be ergonomic for the user. So we really don't want to create any kind of discomfort on the user's case while using your application. So for example, I really don't want to hold my hand in the air for too much time just to perform an action or a specific workflow. So that's really important, and one of the main testing phases you should be aware when designing the application. Another principle is about making your application to work offline. So typically the smartphone's applications always requires internet connection, obviously for our APIs, in order to fetch data, to sync data to our backend servers, so to perform any other kind of actions with the internet connections requires. But on wearables, for example, we don't really need every time the internet connection, or we might have wearables which are independent and they are not connected to the smartphone, for example. So one thing to keep in mind when developing your application is you should keep in mind that you should at least give the option to the user to at least still use your application even when you are in an offline situation. So not saying that your application should work in the same way as with an internet connection, for example, but at least give the possibility to still open your application and perform some of the features which the application gives to the user. Another principle is about the cold start. So when talking about cold start, we talk about the first time when we open our application. So this is more like a tricky discussion to talk about because essentially we know that wearables are pretty limited in terms of capacity and resources. So we have low power, low CPU power, we have low amount of RAM, for example. So we are very limited in what we can do on a wearable device. So we have to be aware of how we use our resources in our application. And if you can, for example, manage in a right way your application in order to use the resources, you could still use a splash screen where you can load your logic prior the main screen of your application. So here we have a situation when Google, we already know that Google has introduced with Adrien 12 specific APIs to use for the default splash screen, which we have now for all of our applications, basically. And it is considered now bad practice to have secondary splash screens when we load the logic specific logic of our application. But in the case of wearables, I would still suggest to still use a splash screen for that, especially if you are very limited in terms of resources. And this is the best way, still the best way on how you can solve this in order to have like a smoother experience while using your application afterwards. So last principle I wanted to talk about is about leveraging the gestures and the haptics of the wearable device on which you are going to develop on. And essentially here we know that on smartphones, we have gestures from some time now, and the navigation is now fully on gestures also on our smartphones. But typically on smartphones, we are still flexible on how we can customize the gestures or how we interact with the navigation on our smartphones, and we can actually still have the old-fashioned way virtual buttons, so with the back, the center button, and the recent button, so that's still a thing. But on wearables, for example, we don't have that, so we have only gestures. So when designing the navigation of your application, you gotta keep in mind also how you could try to leverage as much as possible the gestures and the navigation that the wearable device has to offer. And same as well goes for the haptics. So speaking now about UI and UX, specifically about touch zones. So when we talk about touch zones, we are actually talking about specific areas. I mean, any area in your layout which is considered as a clickable area. So that can be like a container, layout container, text view, edit text, button. Any widget or clickable area is considered as a touch zone. And when we talk about touch zones in general, there is this study of the human fingertips and the mechanics of tactile sense conducted by the Meet Touch Lab, very, very long name, sorry about that, that says that the average human fingertip is about 8 to 10 millimeters in diameter. So essentially, the developers designing applications for wearables should keep in mind that the physical touch zone of the intended area should not be smaller than 10 millimeters. Because if it's going to be greater than 10 millimeters, then we could have a potential risk of tapping something else in the layout, especially if we are going to have different clickable or touchable areas in the layout. And as you can see from those squares, so those squares are actually screens which took as an example from the WS50, so from one of our devices. And if we try to divide the screen into different grids, for example, and if we go to a 6x6 grid, everything is fine, so we don't have any potential risk of tapping something else in the layout. But if we go to a 7x7 grid, for instance, there is a potential risk, but still manageable in some way. And then if we go to an 8x8 grid, that's dangerous, and that's considered as a bad practice, because essentially we can guarantee that you are going to tap something else in the layout while performing the action. And this is really important, because you really don't want your user, while using the wearable device, to tap something else in the layout while performing the action. So that's an important thing to keep in mind while designing the UI of the layout. And here we have like some pretty simple examples of how you could see like a typical screen from a wearable application. So I know there are not pretty, I know there are prettier layouts available around, obviously, but this is just for the sake of showing you that these layouts are simple. You can actually understand what's going on in the screen and what's the action that the user should perform. And at the same time, you can also see that we don't have any overcrowded layouts, so there's no potential risk of tapping something else in the layout, as I was saying with the touch zones. Okay, so talking now about a couple of things related to battery and power management. So the first thing to keep in mind when developing for wearables related to battery and power management is that you should not prevent the device from going to sleep. So don't try to do that, because you're going to consume the battery of the device. And this actually connects to another thing, which is about wake locks. So we all know what are wake locks here, and we also know that there are different alternatives now which you can use in your normal Android development cycle, which gives you the ability to don't use wake locks because they are impactful from the performance of your application. And in the case of wearables, you should not use wake locks at all. So you should not really use them unless it is 100% necessary. And last thing is about testing the dose mode of your application. So you gotta make sure if your application enters and exits the dose mode in the right way. This is obviously when it is applicable only, and this is also to see if the application manages its memory consumption in the right way. And now, speaking about memory management, a couple of things to say about this as well. So the first one is about minimizing the processes of your application. So you gotta try to limit the foreground and the always-on processes. So really try to don't do too many things at once, especially we're running foreground services and the always-on processes, which also connects to the next thing I want to talk about, which is having simple workflows in your application. So it is the best to have like 1 to 2 tasks maximum per workflow, so per screen essentially. Because when designing the application, it is the best to have like a proper screen specifically centered about a specific task that the user should do in that specific screen. So don't try to overcomplicate the screens, because you either are going to get in that area when you have too many components in the layout, so the touch zone issue, and at the same time you don't really want to have too many tasks running on the same screen. So if you really have the necessity of having a screen that should have many components, then just try to divide the screen into a much simpler workflow, and then that's going to be much more easily understandable for the user as well. And then last thing is about the apps resources. So apps resources are really important, and we should be really responsible when using the resources while our application is running. And when I say that, I'm also talking about avoiding memory leaks. So you really don't want to have memory leaks, especially on a wearable device, because first of all, I mean, that's going to be easily noticeable, to be honest, and you gotta make sure to recycle the listeners' callbacks which you might have in the screen in the right way, whether you're going to put the application in background or you're just pausing the application if you're going to the next screen. So that's another important thing to keep in mind when developing the application. So last slide I wanted to talk about, which is something I was speaking at the beginning, which is using wearables for the enterprise use cases. So as I was saying, the WS50 is just one of the devices which you can use for enterprise use cases. But we have, I mean, in general and on the market, obviously, there are many other devices which can be used for the enterprise use cases. And we have 4 different examples in which you can use wearables in order to maximize the efficiency of the workflow of the operator. And in this case, we have warehousing, for example, the item sorting, which could provide line of sight instructions to the workers, moving the scanned items to the proper location of the bin containers. A second example could be about manufacturing on the maintenance side. So you could use a wearable device to monitor the equipment status of the machinery which are in the factories for specific alerts or for the statuses of those machineries.
Movement that inspires.
A third example could be truck loading and loading operations. So we are in the transportation sector here, and you could use a wearable device to support high scanning capabilities. So in this case, the WS50 could be a good example when you can use it for high intensity scanning with audio feedback and haptics in order to provide the good versus the bad scannings. And last one is about retailing. So obviously wearables can be used also in retail, specifically for task management, and this could allow the supervisors to push messages to workers who can then respond, as I was saying at the beginning, with push-to-talk capabilities to respond about the confirmation of the receipt and the completion of the various tasks. So yeah, that was pretty much it. I know there is a lot of talking about wearables in general, and I have stretched pretty much in these 20 minutes, and I tried to put it on like an overview level in order for everyone to understand. So it's really, we haven't even gone into technical stuff, but yeah, I hope you liked it.